Welcome back, everyone. So this is our final week of the term with material. So basically this is the final week of learning new stuff, and then next week is just basically turning in and finals. So we are going to be taking a look at the rest of topic 8. So let's take a look at our schedule for the week. So today, don't forget you have your integration project presentation that is due by midnight tonight. So this is our hard deadline. If you submit it later in the week, it is not going to be accepted for points. So make sure that you submit it by midnight tonight. Okay, and we'll go over the project in a bit. But first, let's get into our 3 activities this week, starting with the identification of GMO crops. Okay, so we talked about GMOs in last week. So, and basically the PCR technique where the gene was isolated and then it was amplified through PCR, polymerase chain reaction. And basically now the gene has been copied over and over and over again until we have millions of copies of it. And so now it's going to be run through this gel electrophoresis, which you learned about last week. And so, of course, you're not actually going to be running it because you don't have a gel electrophoresis chamber at home. So we have given pictures of the gel electrophoresis for you to take a look at. So let's take a look. And what you're going to do is you're going to pay close attention to this part of your workbook. So page 268 in the interpretation of the results. So particularly when it comes to this part down here. So we're going to be looking at the bands, and particularly the GMO related band and the tubulin positive control band. So basically if they're present, both of them are present, then we know that the food has GMO related DNA. Okay, if the GMO related band is absent but the T band is present, then we know that there is no GMO related DNA in the food. Okay, so let's go ahead and take a look at our assignment. So we are down here in T8S7, and so we're not going to be doing the sample. So we're going to take a look at the actual data. So I'm going to show you the data, the student data. And this was from a previous course. I think it's from way back in fall of 2017. Okay, so here's some information that you'll want to pay attention to. Okay, so here we have in lane 1 we have 3,5-S primer. So that stands for the Roundup Ready GMO, and then we have the T primer, that's the tubulin primer. So if both of these are showing, that means, so present and present, that means that the food, it has GMO DNA present, okay? If the first band, the GMO related band, is absent, but the T band is present, then we don't, okay? So let's go back to the bands. So if we take a look at lane 1 and 2, if the first band is present and the second band is present, then we know that whatever snack it was has the GMO. It is GMO. If it doesn't, then it's not. Okay, so we look at this area and we see that neither is present, so we know that that snack doesn't. Okay. So let's go down to lane 4 and 5. So lane 4 and 5, we have the 2 bands again. So we have the Roundup Ready GMO band and the T primer band with original Ruffles potato chip. So lane 4, we don't see a band. Lane 5, we do see a band. So what does that mean for our original Ruffles potato chip? So we have no band for the first one and a band for the second one. So no band for the first one, present for the second one. So that means that it is a non-GMO related food. Okay, so that particular brand of potato chip doesn't contain any GMOs, GMO food. Okay, so no GMO DNA is present in original Ruffles potato chips. But if we go over to lane 6 and 7, we see that the first lane has a band, and the second lane also has a band. So these two bands indicate that Doritos Nacho Cheese tortilla chips have GMO related DNA present in the food. Okay, so so Originals Ruffles potato chips, it is not a GMO food, but we cannot say the same for Doritos Nacho Cheese tortilla chips. Okay, so you're going to do the same for the others, the Juanita's corn chip and the Simple Truth organic blue corn tortilla chip. And the Food Should Taste Good multi-grain tortilla chips. So you're going to compare all 5 of these snack chips to each other and see which ones are genetically modified and contain genetically modified DNA, and which ones do not. So far we see that the original Ruffles potato chip is not GMO, but the Doritos Nacho Cheese tortilla chip is a GMO crop, okay, or contains that GMO DNA. Okay. So in addition to taking a look at that data and kind of reviewing it and writing it down, you'll also be watching a TED Talk on the case of engineering our food. So this will help you answer the questions on page 269 and 270, these questions here. Okay, and this is a pretty interesting case. It talks about, basically what is the good, outcome of having genetically modified food products on the market. So basically, it talks about, some cases where it does actually help certain farmers. Okay, so where did it actually help? So for example, in Hawaii, the papaya, what actually ended up happening to the papaya, and then once we ended up genetically modifying them, how did that help out, and so forth. Okay, so there you'll watch that video and answer the questions along the way. Okay. And then finally at the end, you kind of use the information that you gathered from the gel electrophoresis activity as well as the video, and kind of answer the questions along the way. Okay. So once you have answered all of the questions, then go ahead and post the answers to your selected questions in the student forum below. Next, we're going to move into topic 8, step 8. So are there any limits to freedom of choice? Okay. So let's take a look at this assignment. So in this assignment, there will be some math involved. So just be aware, have your calculators handy. Okay. So some of it is, opinion based, why should we be concerned about population growth rates? But then you get down here and you do some math. So, the entire population of the world could physically fit inside the boundaries of the state of Texas. Texas has an area of, 261,914 square miles. So use the data from the world population, calculate the population per square foot. So, think about the population of the world. So, you might have to refer back to what we calculated in previous, what it was previously. I can't remember. It's like 8.1 billion or 8 billion. I can't remember what we wrote down. So you'll have to look it up, what you wrote down previously. So I'm just going to go with 8 billion. So that's How many zeros is that? So that should be 8 with 9 zeros. 1, 2, 3. I think I have 9 zeros, right? 1, 2, 3. Okay, and then you divide that by the state of Texas. 914. Okay, and then you get the basically calculate the population per square mile for the size of Texas. Okay, so you'll get what the population is per square mile. Okay, and then from there, you'll figure out it takes 1 square mile to feed a 3,700 people without intensive use of synthetic fertilizer. So how many square miles of arable land would be required to feed the population? So think about, if we have 1 square mile feeds 3,700 people, and we have 8.1 billion people, so how many square miles will that be? Okay, so think about, how to calculate that. So 1 square mile feeds 3,700 people. Okay, so you multiply that by how many people on Earth. So I don't remember what the exact number is, billion people. So, calculate that. And then that will give us how many square miles of arable land we need. So currently, here it says 7.9, so you can move that to 7.9 up here. 7.9 million arable, I thought that said population. So if it's 7.9 million square miles of arable land, what is the world population size that the arable land could support? So think about, what our, if we have 7.9 million square miles of arable land, so that would be 7.9 million square miles. And then we can have 3,700 people per square mile. How many people could potentially be on Earth? Okay, so you can calculate that out. And then from there, according to the United Nations Food, approximately 43.5 square miles of arable land are lost every day due to a number of environmental factors. So consider that that daily loss, what would be the carrying capacity in 2025. So from there, you kind of have to do some calculations. So if we're losing 43.5 square miles per day, and there's 365 days per year, then you have to kind of calculate, how many are lost per year. And then from there, take the amount of arable land. So we have total 7.9 million square miles. And then you have to subtract that per year. Okay, whatever this number was, y. And then from there, you have to multiply that by this number by the 3,700 people per square mile to get how many people for our carrying capacity. Okay, so especially, and it's really easy because next year is 2025, so we don't have to calculate it like into the future very much. I think when this workbook was created, it was created back in like 2014 or something like that. So they're projecting it 10 years in the future, whereas we don't have to do that. So it's a little bit easier for us. All right, so you'll be doing some calculations for that. And then from there, you're going to be kind of doing some more opinion-based information based on our previous work that we've done in the past. Okay, so we've gone back several steps. Like, you know, when we talked about the comparison of countries' demographics, where we looked at, you know, education, religion, availability of family planning, to kind of, you know, compare that to their population trends. So use that information to help you kind of come up with sorry, lost the page. Come up with, you know, some opinions for these answers. So these are more opinion based. Just make sure that, you know, I'm not going to grade you on your opinion, but your explanation of your opinion. So explain how religion might pose an obstacle to a stable world population. Explain how improving education or economic status might affect population growth. So you'll answer those questions based on that. And then again, these are opinion based, so I'm not basing your answers on your opinions, but on how well you can justify. Okay? So same down here. All right? So a lot of this is opinion based. So once you've answered those questions, then you're going to post your answers to your student roles in the forum below, and then you're going to respond to at least 2 other students' posts. And when you respond, you'll realize that, you know, you might have similar opinions, but sometimes you might have, you know, slightly different opinions. And of course, if you have slightly different opinions, you don't want to be negative in your discussion, of course, but, you know, just perhaps explain why, you know, you think differently than them in a respectful way, of course. All right, so that will be posted there. And then the last activity of the term are these age structure diagrams. So an age structure diagram, we're going to be constructing using these, basically it's these population pyramids. So we're going to go down to population pyramid in Excel, or I actually like to do this on my own. Because we have a bunch of graph paper, so you can make it in Excel if you'd rather do it that way. There's some instructions on how to do it in Excel, or you can graph it on your own in the graph paper that's provided. Here's a video, population video overall that you can also watch on how to construct one. But basically what you're going to do, let me go ahead and show you, is each student's role is assigned 2 of these cohorts. Okay, so if you take a look at, for example, student 1, your cohort 1880 and 1970. Okay, so you'll be graphing like this one and this one. To set up an age structure, basically the way you set it up is you'll have these age intervals. So let's see if I can draw one that doesn't look horrid. So basically you draw like a y-axis in the middle, and then you have the ages along the sides, okay? Or the population size, I should say, not the ages, but the population size. So if I look at our cohorts, so I can see like our population sizes, they range from, you know, here 20 to about, you know, very small. So I'm just gonna go maybe, I'll do like by 2s. So this will be 4, 8, 10, you know, and so forth. Okay, so I'm just going to go all the way out to like 20. I don't know what I'm doing. And then this will be 20 over here. So this is population. And on one side I'm going to have males, and the other side I'll have females. And then on the y-axis will be the age cohorts. So I might have like the 10 to, or the below what were the age ranges? You know, below 10, and then 10 to 20, you know, 20 to 30, 30 to 40, 40 to 50, and so forth. Okay, so these are like the age cohorts. So then I graph. Okay, so if I look at the under 10-year-olds, I have 20.6% of the population are male. So that would be all the way out here. So this would be all male. Okay, and then for the females, the same, about 21%. So that would be, so you're going to get a wide base. And then for the, 10 to 20-year-olds, you have 16.9% for the males. So that goes to about here. And then for the females, it was like 18%, so that goes to about here. So basically you're building like a little pyramid. It'll look something like this. And then it gets kind of skinnier and skinnier as you go to the top, okay? So it kind of looks like a pyramid. So you'll end up with, a lot of, especially in the earlier years, you'll have a lot of children and then not very many adults or older people, okay? And then as we make our way through later on, you'll notice that the population kind of shifts. So just looking at the numbers here, we have most of the population are younger, very few older people. But if we look at like 1990, we see, not as many really young kids. It's dropped down to 13% of the population are under 10, whereas previously it was, 20% of the population. So it dropped, okay? We have quite a few people that are, in the middle ranges compared to in the 1880s. And then we have, quite a few people that are living into their 90s compared to in the old days. So the population shifts, and as it shifts, the pyramid shifts. It might, start looking more like, I don't know, like that. So it kind of looks different. So you'll be graphing these population pyramids. So you'll graph yours, and then kind of describe, what historical factors took place that contributed to your particular, what was going on during your period of time. So again, you can kind of refer back to the previous activities that dealt with the populations during that time. Okay, so that's the age structure. Let me go back to our assignment. Okay, so that's the pyramid. So you're going to post your pyramids for your cohorts. And then you're going to take a look at, so this is just for the United States. Next, we're going to compare the pyramids for countries. So you've each been assigned 2 countries. So you're going to do the same thing, but instead of posting for, over time, you're going to be posting for different countries. Okay, so use the website provided. So we have a website provided, so Population Pyramids of the World. Go down to the Population Pyramids of the World. And you're going to see, so basically you can change to whatever country you've been assigned. So let's see, what's one of the countries? China. Okay, and you're basically going to sketch that particular country. Okay, so if I was going to look at China in my age structure, ignore that. So China. Okay, so this is what it looks like now. Okay. But let's say, I want to see what it looked like, back then. So I can go back to 1950. So this is what the age structure model looked like in 1950. Okay, so look at that nice triangle. Okay, then I need to compare it to what it looks like in 1980. So then, I need to add some years to it. Oops, I went a little too far. So look at what happened in 1980. And if anybody knows their history, what happened in 1980? Okay, that's when their one-child policy went into effect. So suddenly you see a lot fewer kids 10 and under, or in this case 5 and under. So you kind of see this little bubble form. And then, so you'll draw that one. And then you'll project forward to 2010. Oops, I went. And see what happened to their age structure. Okay, so you'll compare the country for three time periods. So you'll do that for two countries, two of your assigned countries, and post that. Okay, and then finally you'll answer your assigned questions and post those answers. So you'll get a chance to not only look at our country over the years, over a century, but you'll also look at different countries and their, what happened to them over, basically over 60 years. And so, you can see what happened to them and kind of see if their populations are stabilizing, are they continuing to grow, and so forth, and answer those questions. Okay. So that is, so post your answers in the forum, compare your answers to those in your groups, and think about, did you all get the same answers? All right. So that is it for this final assignment. So those assignments are due Friday. Okay, so notice the deadline is a little different, and the reason for that is because we want you to get your answers back, or everything graded before you take the final, which starts on, I think it's Friday or Saturday, I can't remember. All right, so you have just 3 assignments that are due, along with your textbook, finishing up reading that. Okay, in addition to your activities, remember you have your poster presentation that is due by midnight tonight. Now, once you've submitted that, let's take a look. You're going to go back to your poster presentation. So you're going to be submitting this, and once you've submitted it, where does it say? I guess it doesn't say. I think it says back here. Once you've submitted it, then you're going to take a look at 6 other presentations. Okay, so you're going to scroll through the list and take a look at, choose 6 presentations and look through them. Okay, and think about 2 to 3 questions that you want to ask. Now, if we look at the rubric here, okay, so, 18 points I'm going to be grading you based on this rubric is just on your presentation. But then 6 of these points will be based on the questions that you ask, okay? So these questions, so 1 point per presentation that you ask, student asks questions that are different from other questions already posted and that relate to the presentation, and asks many, total questions. So 2 or more for each presentation review. So you're going to need to ask 2 or more questions for a total of 6 presentations, okay? And, ask questions that maybe you're curious about. So maybe, something that while you're looking through the presentation that maybe the presenter sparks your curiosity, you want to know more about, or maybe, the presenter just didn't dive deep into detail enough, or, just something that maybe is related to their presentation that maybe they know the answer to, that they can answer for you. Okay, so you're going to ask 6 questions, or 6 questions of 6 presentations. So you'll ask those in the replies of their presentation posts. Okay, so those are due by Thursday midnight. Okay, so you're going to ask questions of 6 presentations by Thursday midnight. Okay, and that's a hard deadline. Then You are going to answer the questions that your fellow students have asked of your presentation no later than Sunday midnight. Okay, so you're going to answer the questions that your fellow students have asked of you. Now, because Thursday is a hard deadline, if any student asks you a question after Thursday, you don't have to answer it. Okay, so if they asked you a question on Friday, you don't have to answer it. So just, it goes both ways. So this is a hard deadline. If anybody asks you a question later than Thursday, you don't have to answer it. Okay, so just be aware of that. So your questions are due on Thursday, and then your answers are due on Sunday. Okay, so that is the integration project that will be going throughout the week along with your activities. And then finally, you have your last, I guess, lab report in quotation marks, because it's kind of more like a quiz setup. And so I'm going to show you that. Okay, so this last our last lab report in our workbook, to kind of make it a little bit easier on both you and me, we've kind of set it up more as a quiz than a formal lab report. So I'm just going to show it to you. This is what you're going to get. It's not timed, so take as long as you want. But it's still like a 30-point assignment, just like your formal lab report. So starting on page 30, or 330, I'm sorry, in your workbook, you'll have your formal lab report. So you want to have that handy when you are working through this quiz. Okay, so have that handy while you're working through. So the first question: what was the question the lab was designed to answer? Well, I'll give you a hint. Here it is. Okay, so just copy that down. So that's a giveaway. Answer that. It's 1 point. What was your hypothesis for the experiment? Okay, so remember, a hypothesis includes both the answer and the question, and why it's a reasonable answer. So you might want to go back to where we made our first hypothesis. So I think it was way back here. Okay, so this is where you can, is this where we had it? You've been assigned. Yeah, so your hypothesis is here. So you can go back and see what your original hypothesis was. And then you can jazz it up if you need to, but don't change it. Just make sure that it is in a hypothesis format. So let me go back into my, there it is. Continue your attempt. Okay, so make sure that you have your hypothesis written out, and so that it answers the question. So how do increases in carbon dioxide affect biomass production and primary producer? And then make sure that you explain your reasoning behind your hypothesis. Okay. Next, what was the independent variable? What was the dependent variable? Which were you measuring? How did you measure it? So those are questions that you can easily answer. Use your notes and or textbook. Explain what it means to be an autotroph and primary producer. So that's pretty easy. Okay. Use your book or notes. Describe photosynthesis. Okay, and by the way, when it says use your notes or textbook, use your book or notes, make sure you cite. Okay, if you're using your book, just say Odigia. If you're using your workbook, just say workbook. It's just so you cite. Here we have a multiple choice question. And then here, how was the amount of carbon dioxide varied between the habitat containers? Okay, so, think about that. List some variables that were intended to be controlled or consistent. So if you don't know what that means, so controlled or consistent, think held constant. So what was the same between all treatment groups? Or what was the same between all habitats? There was one habitat that acted as the negative control. So which one do you think it was? Was it habitat 1, 2, 3, 4, 5, or 6? And explain why. List the ways that productivity and total biomass were measured. So think about that. So think about both the method throughout as well as the last day. Moving on, class results figure 1. So here you're going to need to graph, okay, so graph the average weekly grass growth. Now notice this is the average weekly grass growth, okay, so this isn't just writing basically everybody's total average weekly grass, so you need to average out all the habitats averages, okay, so for example, so for habitat container number 1, there were 2 people, so don't just give me both people's, averages for each week. So you need to average theirs together and then graph that average. Okay, so for habitat number 4, we had 3 people. So don't give all 3 of theirs in 3 different lines. That would just be confusing. So make sure that you average their numbers together and then just graph that line, okay? So, and then upload the graph, okay? This should include the data from all the habitats tested. So you should have 6 lines, okay? And those are the bios that you can do. And then for the second one, upload your graph of the total shoot biomass and the final average root biomass. So this data from all the habitats tested in your class. So you could do it as 2 separate graphs if you prefer. So you can have one for the shoot and one for the root, or you can have it as all on the same. Okay, just make sure that you distinguish. If you're going to do it on the same, you have a legend. Okay. And then write a brief statement that describes what you see in your graph. So make sure, again, this is looking at the trends in data that you see. You're not interpreting it. You're not going to be accepting or rejecting hypotheses at this point. Okay? So basically, point out any correlations in the data that you see, any trends in the amount of productivity as the amount of carbon dioxide increases. Okay, and then here is where you're going to finally interpret the results. So you might want to refresh our memories of what your hypothesis was and then explain, was it supported or not, using the evidence. And then use background theory about biomass production to suggest possible explanations for the relationships you observed. Okay. Discuss whether or not photosynthesis may be part of the explanation. And then you're going to bring in some information related to primary producers and the food web and trophic levels and things like that as far as amount of biomass. And then you have some other parts that you're going to include, and then, sources of error, and then other questions that you can ask, okay? So that's basically, it's the same thing as a lab report, but we kind of broke it up into these easy parts. And notice you can start and stop the quiz along the way if you want to break it up, okay? So this is a 30-point assignment that is due by Monday, okay? So Monday midnight, all right? Along with your topic 8 quiz, all right? So don't forget, you have all of these assignments. I will send reminders throughout the week, so just keep track, because you do have different dates for different things. And then finally, your final exam will be coming up. I think it starts. When does it start? It starts Friday. Okay, so it will open up Friday for those of you that are planning to take it through ProctorU, but it's going to be taking place throughout the week, and then for next week. And that, just like the first, the midterm, you do get these 2 choices, but just be aware that there is still a lot of writing. I don't know why they make you write so much on these multiple choice, but that's what is there. But this, you get 2 hours instead of 90 minutes. but just realize that there is more to it than the last. And it is cumulative, so make sure that you are doing the study guides along the way. If you have any questions, please feel free to reach out. Otherwise, good luck.